Today's sponsor is Datadog, a real-time monitoring platform that unifies metrics, logs, and distributed traces from your cloud containers and orchestration software. Datadog's container-centric monitoring features allow you to track the health and performance of your dynamic container environment. The Container Map provides a bird's-eye view of your container fleet, and the Live Container View searches, groups, and filters your containers with any criteria, like tags, pods, or workspaces. To start monitoring your container clusters, sign up for a free trial today, and Datadog will send you a free t-shirt. Visit datadog.com/container-cloudcast to get started. That's datadog.com/container-cloudcast.
Cloudcast Media presents from the massive studios in Raleigh, North Carolina. This is the Cloudcast with Aaron Delp and Brian Gracely, bringing you the best of cloud computing from around the world.
Good morning, good evening, wherever you are, and welcome back to the Cloudcast. We're coming to you live from our massive Cloudcast studios here in Raleigh, North Carolina. And we have a very special episode this week. You'll notice this one came out a little bit later than usual, and that is because our guest today, our guest is something that was an announcement of sorts and something that was under embargo until today. So we wanted to help them out a bit, and we will be talking with them, and that's Louis Ryan specifically, and Christian Posta, and we'll be talking with them right after the break. But let's jump into cloud news. We've got just two articles this week. It's kind of a slow news week, but I think they're pretty important ones. First of all, Microsoft. Microsoft is finally shutting down basic authentication. And this is something a long time coming, and they've announced it a couple times and then pushed it back a couple times, but now they're doing the turn it off and see what breaks method to everything. So if you're wondering what this is, think of it as basically all the old ways to really get to Exchange and Exchange Online, MAPI, POP, IMAP, Exchange ActiveSync, Remote PowerShell, Offline Address Book, all of these other things that have just the older technologies for authentication. And let's be honest, it just isn't up to speed. And there's just much better ways these days. And I equate this, they do say, there's a lot of probably pretty old systems that might run on this, and who knows exactly what's going to happen. So they do give you the ability to re-enable this on one time per protocol. So, again, if your company's not quite ready for this, something is super critical, it's some server that's in the back corner that's running some scripts somewhere and no one knows how to do it and it broke everything. Well, great, turn it back on until we can figure this out. This reminds me, by the way, of back in the old days, I used to do physical to virtual server migrations, and we would go through and do, inventory of data centers. And sometimes people didn't know what the server in the rack did, but no one wanted to shut it off. So we would shut it off and see what breaks. Well, it's almost a little bit of like that mentality all over again. There is some folks that are going to be forced to modernize some of their applications and some of their ways of doing business. And if you're interested in that, there is a link to the article for more stats and more details on that. Our second one is about open source software, and past Cloudcast alumni Joseph Jacks and again, OSS Capital, they put out a really good report, and it was all about trends. Last a little over 2 years, January 2020 to August 2022. I like the tagline here: 500 rounds of funding, 360 startups, 340 projects, and 230 venture capital investments. Really powerful of exactly where open source software is going, and a little bit about the trends. Obviously, this all increased, but increased in all stages, seed to pre-IPO, across all geos, all sectors. No matter where you're looking, this is making an impact. And a lot of us will sometimes think of trends and we think, oh, SaaS companies. SaaS companies is where the growth is and where this is going. Well, again, remember core technologies, right? Confluent would not exist without Kafka. Databricks would not exist without Spark. HashiCorp would not exist without Terraform, Nomad. Red Hat would not exist without Linux, etc. So I think this is a really good article, some really good stats on this, and also is pretty eye-opening when it comes to data and trends over the last, let's call it 2.5 years, and how things continue to grow as well. So with that, I'm going to wrap up Cloud News of the Week. And as I mentioned before, coming up after the break, we have a bit of an announcement and something definitely worth listening to. We're going to be talking about Istio Ambient Mesh.
Buffering. How annoying. Did you know that 17 out of 20 people stop watching a video because of stalling and rebuffering? Don't let your users click away to a competitor's site. If your business lies in online media, rely on CDN77 to deliver a seamless online experience to your audience. CDN77 is one of the leading global providers of content delivery network services. They power the world's most popular websites and apps, such as Udemy, ESL Gaming, live sports TV, and social media platforms. Aside from their massive and redundant global network, you're going to love their no BS attitude and skilled team of engineers ready to help 24/7. No chatbots, no tickets bouncing around unresolved for days, just people who know your use case and can immediately help you pinpoint and fix the problems. Don't wait until your users run out of patience. Go to cdn77.com/cloudcast and ask for a free trial with no duration or traffic limits. That's cdn77.com/cloudcast. And we're back. And folks, as you know, the service mesh space has been one that has gotten a lot of attention. It's obviously grown quite a bit as we've seen the growth of cloud native, of Kubernetes, of microservices. And, we saw a lot of growth and interest once again in Istio. We've seen it for a number of years, but we saw it once again as Istio was introduced as a formal project into the CNCF here back in the spring, early summer timeframe. And so, we're seeing more and more companies that are interested in Istio, more and more kind of interest in service mesh as, again, microservice continues to grow. And today we've got sort of a big announcement that's coming out of the Istio community around a new technology, a new sort of variation within Istio called Istio Ambient Mesh. And today we've got two folks who are deeply, deeply involved with this and also deeply involved with Istio. So very excited to have both Louis Ryan, who is principal engineer at Google, as well as Christian Posta, who is field CTO at Solo.io. Louis and Christian, welcome to the show. Great to have you on.
Thanks for having us, Brian.
Thanks for having us, Brian.
You bet. So before we dive into the announcement and the things that are happening in the community, give folks a little bit of an overview. Louis, you can go first. Kind of your involvement in Istio and your role in helping shape where it's been going.
So I've been working on the Istio project since the dawn of time, effectively. I helped bootstrap the project internally at Google. I've been actively working on the project ever since. Right? It is my day job. Yeah. Both the open source side of it and Google's commercial offering, those service mesh. And so, I play lots of different roles on the project, both technical and, in kind of steering, everything that the project needs to be successful. And so, I'm as happy to be working on it today as I was probably 6 years ago.
Yeah, very good, very good. Christian, how about you?
Yeah, so I've been interested and involved with the Istio project since around the end of January 2017, from even before it was publicly announced, and got really, like I said, interested in it, and I saw it as a sort of evolution of what people were doing in their distributed architectures by using libraries and all kinds of other stuff, and fit a lot better in a Kubernetes world for sure. I helped evangelize it, get it into Red Hat, where I was working prior to Solo, and then I've been working with some of the early customers at Red Hat, and then now I've been at Solo almost 4 years. Been working with customers adopting this sort of technology at large scale, and written a few books about the topic as well.
Good stuff. So yeah, you guys you've been there in the earliest days. You've got the scars to prove it, and as people like to say, you've seen it used in anger. So very cool. Both companies made a fairly significant contribution, the ambient mesh sort of element, to the Istio community today. Louis, get us started. Give us some background on what Ambient Mesh is, and then maybe more importantly, what's it trying to solve? What was the purpose for driving this new set of capabilities?
So I've been working on Istio and seeing people trying to deploy service meshes in production for quite some time now. Both Istio and other service mesh solutions that exist out there in the ecosystem. And through all those engagements we've had with customers and users, some things have become clearer about what a service mesh should do and what a service mesh shouldn't do, and also, what are the phases of adoption within a company and what are they adopting for? Service mesh, are trying to do, a bunch of different things, and we think those things belong together. But the adoption cycle for each of those capabilities within a service mesh is different, right? If you look today, we see most users coming to get a service mesh solution, and they're coming for one of two reasons, and one tends to dominate the other. Usually, customers are coming because they want to get MTLS rolled out in production at scale for a security or compliance reason. The other class of customer, you'll see a smaller number of customers come and say, well, we're coming to get service mesh because we want to get observability for what we have running in production because we don't feel like we have good insight into the interactions between the services that we have. But the first one does tend to dominate the other one.
Right. Yeah, I've seen it a lot.
And then one of the challenges you see with most service mesh solutions is what I describe internally as the burrito problem, right? Okay, I want to solve for MTLS in my enterprise, but I'm going to install a service mesh and it's going to give me MTLS, it's going to give me observability, it's going to give me all these kind of L7 traffic controls, right? And policy controls and other things that I could start to do. And that starts to feel like a large burrito that a user has to eat as opposed to a taco for each one of those problems. And so we've been looking for a long time to try and solve this so that people can walk up the kind of complexity curve of their solution and get each of those values somewhat more independently when they start to roll this stuff out in production and not absorb risk, right? So if I want to roll out MTLS, I shouldn't take any production risk from code that does complex L7 processing so I can implement like L7 load balancing, right? And so we're just trying to make the adoption curve more gradual for users. And so, we've been looking around, running experiments, talking about different ways of implementing this. And after a while, it became pretty clear that this architecture that we're talking about today, what we call Ambient Mesh, is a pretty good set of trade-offs to help customers walk that path and give them that path in a better package. And so I can obviously, we can talk about the details of what we've done relative to the current model in Istio today from an architectural perspective and the different properties of the system. But that's the reason.
Yeah.
And right, it is very important because people have to maintain service meshes in production at very large scale. And people want to be able to roll them out quickly, right? And anything that presents a barrier to either of those two things is a problem, right? It's the most critical thing we actually have to deal with.
Right.
It's far more important, say, than, am I adding, 0.1 of a millisecond of latency to this HTTP request, right, in the 98th percentile, right? It's the adoption curve and the maintenance costs.
Right. Yeah, and I think I like the way that you explain that. I think I find oftentimes as people think about the challenges they have with microservices, like it's not that hard for them to wrap their head around the concept of, okay, we've taken something that previously was sort of monolithic, lived in one or two boxes. We've now distributed that across the network. They get the concepts of service discovery. I need to secure that traffic between them. I need help in figuring out what's going on with it. But as you said, sometimes people struggle with this idea of, this is a service mesh is a technology that kind of overlaps concerns of operations teams, but also, overlaps capabilities or concerns of application teams. And sometimes they sort of go like, do I have to have all of it? Does all of it matter to me? Do I need all of it? And it sounds like you're very much kind of trying to address that idea that, there are different parts of a service mesh that apply to different groups, and you're trying to make those more modular or more accessible specifically to what helps them.
Mm-hmm.
Yeah. Christian, let's walk through some of the core elements of service mesh. I think a lot of our listeners are going to be, familiar with Istio and the idea of, there's a control plane and there's data plane proxies, but sort of walk us through, what are either the core elements of what's in Ambient Mesh, maybe what's different than what they maybe have known from sort of traditional or standard Istio, if you will.
Yeah, happy to walk through that. But one thing I do want to kind of point out is that, and following on to some of what Louis said, that when I've seen people, and we at Solo have seen people adopt Istio or start with Istio, let's say, they do want to get to mutual TLS. That's usually the big win, the big feature that people start with. But many times I've run into, hey, yeah, we're using Istio. Okay, cool. What parts do you have? Well, we just started. All right, what parts? We're just using the Istio ingress gateway. That's where we started. That's what we've been using the last 6 months. That's where we started. That's what we've gotten. We're still trying to figure out the rest of it. And it's an interesting observation because, that's the part that doesn't involve the sidecars at all. And they're just getting, familiarity with Envoy and Istio, the control plane, the APIs, that kind of thing. But as then they start to roll into, additional capabilities, that's where they bring some of the data plane components. They start to expose, use the sidecar model and add applications into the mesh and so on. And so if you look at what Ambient is focusing on, it's really the data plane. How can we optimize the components in the data plane to make that ramp as as easy to walk as possible, like Louis was mentioning. And so some of the core components in Istio stay the same. There's control plane and there's data plane. The data plane is where we start to do some of the optimizations, and there we start to split out some of the handling between what's layer 4 and what's layer 7. So if you're just starting to adopt the mutual TLS capabilities of service mesh, then start with just the most minimal pieces that you need. And in that case, that's some of the layer 4 pieces. And then as you grow the capabilities of things that you need, then introduce layer 7, maybe for specific services where you may need it, and opt into it gradually. So I mean, I can go into more detail, what those components look like, where they run, how they run, but that's kind of the high level optimization of the data plane.
Okay, yeah, and I think we'll get into that a little bit. I'm trying to ease people into what's new and then where we're going. I'll throw this out to either one of you. Sidecars. For anybody who's followed service mesh, sidecars, the idea of I want to introduce a proxy along with every application, every pod, such that I've got a control point, has always been a core element of Istio, right? It allowed Istio to say, I've got a place where I can bring in security. I've got a place where I can bring in a known observability point. I can put a proxy in there for resiliency. Now we're starting to hear about in various service mesh circles and in Istio, this sort of discussion of like sidecars versus not sidecars or sidecar-less. Can you kind of explain if we're hearing those terms, like what does it mean if somebody says something's sidecar-less, or why would that discussion come up, and maybe also when do I need a sidecar, when do I not need a sidecar? Kind of, can you frame up that conversation that seems to be bubbling around in the service mesh community these days?
I can take a stab, Christian, and then maybe you want to. So, like everything here, right? A sidecar is an architectural unit, right? That is a means to an end.
Yep.
Like we talked about the core capabilities of service mesh, right? Zero trust, observability, policy controls over networking and authorization and things like that. Mm-hmm. So if we take like one of those capabilities, like MTLS, Sidecar is definitely a way to achieve that. That's what we did in Istio. That's what most of the service meshes do.
Right.
What you can care about, right, as an application owner or as a platform owner, are the properties of zero trust being maintained, right? Am I getting that feature? And am I getting it in a way that is secure, trustable, reliable, right? All the security properties that you're actually hoping to get out of the system. Sidecar is one way to achieve that goal. Right? If I weren't doing MTLS and I was using some other kind of network crypto technology, I might be looking at a VPN, right?
Right.
And there are plenty of VPNs out there. When you had the ChainGuard folks on recently, not ChainGuard, sorry, other folks on recently talking about WireGuard, right?
Right.
An excellent VPN. So there are actually there's more than one way to do that. What we care about and what users should care about is, are the properties of zero trust in the network maintained, right? And am I able to meet my compliance requirements, right? Compliance is a big reason why people want TLS. And so what you want is to get that capability for the lowest cost. Right. Sidecars were convenient because we could bundle all the distinct capabilities together into a unit and deploy it with the application. But that's not always the ideal, right? Particularly if you're trying to walk up this kind of complexity chain. And so if you look at other solutions that are talking about sidecar-less, really what they've done is they've gone and moved that technology out of something that's running basically bolted onto the application, which is what a sidecar is. Mm-hmm. And they're running it as infrastructure, right? Hidden from the application, right? Typically in Kubernetes, they're running it as some kind of daemon that's sitting on the node performing the same function. Okay. And what you want to do, right, particularly in the case of something like zero trust networking, is if you're going with one of those two models, sidecar or something that's running on the node, are the security properties that the system maintained? And then you're going to look at and say, okay, well, which is then less intrusive to maintain and operate? And so our goal, particularly with Ambient, was to say, okay, well, we know that sidecars have a maintenance and operability cost that presents sometimes challenges for platform owners. And the argument has always been, well, that's been a good trade-off because you can't get the properties of zero trust, right, by doing something other than sidecar. And we spend a lot of time thinking about ways to do this without creating that trade-off. And we think we've actually achieved that effect with Ambient. We think we can maintain the strong properties of zero trust networking without introducing additional security risks. And we actually think in many cases improving the security profile of the system, while also removing the operability costs and the kind of cognitive costs of having a sidecar bolted onto the application. Okay. Now, there are other solutions out there that have tried to do the same thing. And, obviously we have to be, it takes a lot to work through and think about, the security properties of the system. But we certainly think it's achievable and that's what we did in Ambient, to maintain that strong zero trust networking posture.
Yeah. And Christian, I want to kind of come back to your offer to say, let's dive into this a little bit. I like the discussion of, because I think sometimes as we talk about these things as trade-offs or prioritization, it's sidecar, proxy for every application. Sometimes people say, well, maybe that's a lot of overhead, or that's computationally expensive. But if we start to talk about a different pattern, as Louis mentioned, of how we do zero trust, the goal isn't to make things less secure. The goal is, let's have some flexibility without losing that zero trust. Can you kind of walk through what architecturally is sort of changing or is optionally changing from a sidecar and an architecture sort of workflow pattern? What applications are going to see what the service mesh is going to see?
Yeah, so it's good that we're pointing out that the various on this spectrum of where the data plane technology ends up, whether that's in the application itself, in libraries or frameworks, or in some centralized gateways or shared node proxies or sidecar, or somewhere along that spectrum. There's no question that there's been, you have to think about it in terms of trade-offs.
Yep.
And like Louis said, and I agree, we've gone through, having worked on service mesh for 5.5 years or 6 years, whatever it is, and Louis probably longer internally at Google, but we feel like we've arrived at the right balance or a good balance where we maintain the properties that we set out to achieve, and we take the trade-offs where we can and optimize the areas like the data plane into the layer 4 components and the layer 7 components. So in the ambient model specifically, we do run a shared node proxy. If we're thinking about Kubernetes, that like a daemon set on each of the nodes that is responsible for layer 4 connectivity. So in the sidecar world, the traffic leaving a workload is trapped and then redirected into the sidecar. And what changes here is now the traffic leaving the workload is trapped and redirected into this node-based proxy. And this proxy only handles layer 4 capabilities, opening connections, establishing mutual TLS, grabbing some telemetry. It doesn't do any of the fancy, retries and header-based routing and other things that you would see in layer 7. And so that reduces a lot of the complexity. It reduces the surface area of attack. And we term this in the ambient architecture the U proxy, the micro proxy, this smaller, slimmed down proxy that's handling basically connections on behalf of the applications that run on that node. And we've separated out, like I said, the layer 7 capabilities. Those are opt-in. If you do happen to have layer 7 policies that need to be enforced for traffic going to a target application, then we can put that proxy in line on the data path at runtime, and the traffic can then flow through that proxy. We can apply the layer 7 capabilities there, and then send it off to the target destination. So the workloads themselves, they don't see sidecars. They don't see, having to restart and injection and some of the challenges you see, which container comes up first, or, what that race looks like, and whether or not you can communicate over the network because the sidecar is not ready. The workloads, maybe they're already deployed. Maybe they get deployed without a sidecar, just normal Kubernetes deployment manifest. And then the ambient mesh, which is sort of just hanging out there, takes control of the traffic, and then keeps the properties of the service mesh that we've had before.
Okay.
Yeah. So Christian kind of mentioned kind of two key things there. The ambient mesh, right? You don't have to do any of the injection stuff at all to enable or even disable whether an application is participating in the mesh.
Okay.
Right. You can actually have an application running and, set a control to say, I want this application to start being part of the mesh. You don't have to restart the application. You don't have to do anything, right? It will just start speaking through the mesh. And if you don't want that, you can turn it back off.
Okay. So it makes it more transparent for the applications than maybe previously was.
Right. And a lot easier to adopt as a result, right? Like I can run an experiment, right? Because I don't have to go and if I have a long CI/CD chain, right, I'm a platform admin and I want to go test this out, I don't have to go start all the way at the back of my CI/CD pipeline to kind of test this, right?
Yeah.
I can just go and turn it on and then turn it back off again, right? Using APIs. And I can do that, at any granularity that I want. I can do it down to the pod level, namespace level, right? Whatever I want, right? Okay. Because it's so dynamic. And that's a hugely important property, right? In what we see as a struggle for customers to kind of adopt mesh because of injection and everything else that sidecars have to do, it impinges on their ability to perform experimentation and do flexible rollout and control.
Yeah.
And that's actually one of the bigger, it's one of the things that elongates the kind of mesh adoption cycle in large deployments. The other thing that Christian mentioned about is we can put the L7 capabilities into the network dynamically. And what we're really saying there is I can have, like advanced L7 load balancing, or, decoding this header and extracting a credential, or whatever the L7 capability is, sit in the network. And if you write a policy that says, I want you to decode and do this routing, then the mesh will know, once you've written that policy, it should send the traffic through something capable of doing that. And if that policy doesn't exist, it doesn't have to, and it can take a more direct path. Right? And so there's this notion that the L7 capability exists somewhere in the network, and the mesh is just dynamically enabling it or disabling it based on what you really want to deal with as an application owner, which is writing the policies that control what the traffic does. And I don't have to care about how that's deployed. It just happens in the network. And that's actually why we call it ambient mesh, because it's just there, and it starts working when you write the policy, and it stops when you remove the policy.
Yeah. So as I'm listening to this, I'm hearing a few things that seem very beneficial. The first being, for example, in sort of standard Istio, where I have a proxy deployed per pod, as a sidecar, we now have the ability, if that's not needed for all layer 7 functionality, that we can make that a node level proxy, which seems to do two things. One is it's probably going to reduce just the amount of overhead. So you imagine you have 1,000 or 100 pods on a node. We sort of shrink that down to, say, one proxy. So we're going to see cost reduction. We're going to see overhead reduction. The second piece seems to be it's a much more transparent system from an application perspective. So like you said, applications don't have to know as much about the proxy logic that was associated before. You can experiment easier. I'm guessing when upgrades and rollouts happen, that makes things simpler. But you don't lose that layer 7 capability or that layer 7 security. If you want it, it's now become a more dynamic, sort of dynamically insertable thing as needed. So it feels like you said, you're taking a couple of things that people were frustrated about, or maybe wasn't optimized before. You're taking some of that away, or you're making it more flexible, but you're not giving up. You're not saying, well, it's less secure or it's less. Right, you're sort of getting the best of both worlds, it seems like.
Yeah, absolutely. I mean, the one thing we cannot do in service mesh is have a weaker security posture, right? So we have to, right, like that's the invariant.
Yeah.
Any improvements that we make can't detract from that at all.
Yeah. And one of the things you'll see in the architecture is that at layer 7 specifically, we didn't try to just say, hey, there's just one big gateway for everybody. What we said, and we wanted to keep similar, isolation that we get with sidecars. We said that, each workload or each identity would have its own policy enforcement points, just like we do today in the service mesh. So that, I think that's, if you look at some of the implementations of service mesh in general, either the ones in the past that have tried to use shared nodes, node proxies, that kind of stuff, and how that thinking has evolved. I think we're able to keep some of that same properties of isolation in the service mesh than what we did in the past.
Gotcha. Both of you get a chance to work with companies. People are running Istio today. Let's say they're running 113 or 114, whatever version they're running. What's sort of the expected process? So obviously this was contributed to the community today. It'll get into a main release at some point fairly soon. What would we expect if somebody is currently running Istio? Obviously I'm guessing you can just sort of upgrade. You'll get ambient as an option. Will you be able to run sort of, I'll call it traditional Istio mode, sidecar mode and ambient mode? What's the thinking there? Would they have to be different clusters? Is it just a configuration level? What sort of flexibility will people have if they look at this and say, hey, I may need both as opposed to only one mode or the other mode?
So let me take a stab, and then Louis can add more color. But I think it's really important that we be able to run co-located with existing deployments of Istio,
Yep.
which means Sidecar, and that we can iteratively, and like Louis mentioned, iteratively and experimentally, enable ambient mesh into the cluster. Things like using labels and selectors to be able to do that is extremely powerful. But maintaining that compatibility between, hey, this workload has no sidecar, and these workloads that are in Istio already that have a sidecar, and be able to apply mesh policies even to those ones that don't have sidecars, and make that interoperable is extremely important.
Got it. Cool.
I don't know if you wanted to add more.
Yeah, I mean, it's certainly absolutely a goal, right, to provide interoperability, right? And so we're extremely cognizant of what that means, right? Because we know people with big deployments, and we would never recommend that people switch from one mode to another, right? Fleet-wide, right? That's not part of our production practice. That's not what we would recommend. And we built, service mesh to help people not do that, right, for their own applications.
Right.
Over time, right, as we gain feedback from users and we optimize the system and other things, I suspect that ambient mesh will, start to be the more widely used solution. We are doing this for a reason, after all, because we think it's better. But we also know that that's going to take quite a significant amount of time, right? These are big enterprise customers, right? We're talking very large deployments. They don't do anything overnight, nor would we ever expect them to. And so we will provide the tooling and controls to help people, migrate if they want to, and not if they don't.
Yeah, no, it's good stuff. There's nothing worse than really promising technology that says the only way to get there is a complete break from the past to sort of move forward. So good to hear that that's a priority. I'll ask one last question because I know you guys are both very busy. Obviously, this is part of the broader Istio community. They're seeing it. The technical teams are digging into it. What are some of the areas you'd expect over the next few months, 6 months or so, that will be new areas around ambient, maybe that get accelerated, that get additional work? Somebody said like, hey, what's the roadmap of this thing for the next 6 months? What do you think maybe some of those areas might be as the broader Istio community really digs into this?
So obviously what we're releasing is, in Istio parlance, an experimental feature at this point in time, right? So we don't, not all the problems are solved.
Sure.
The focus has been on, validating that this model works, that we can maintain the security properties of the system, that we, hit our targets in terms of operability, right? Which was, the thing that we were really trying to solve, in addition to the kind of ability to walk up the feature complexity stack for end users, right? So we want the basic properties of the system to work. It is not fully optimized for performance, right, or footprint or things like that. So I would, people should expect in subsequent releases to see performance and resource utilization and other things start to become more in line with what our ultimate targets are. So that, there's the basic kind of maturity of stuff as we go from experimental to alpha, beta, and then to GA. So we're going to walk that maturity track and do that with the community at large. Then we're going to look at like integration points. I think will be the interesting and exciting thing for the broad community. We've been very careful with the design here to enable integration at a variety of different points and for a variety of different reasons. Envoy itself is a great platform for enabling integration, right? You can extend it by building your own policy system and having Envoy call out to it. We've created a stronger separation now between the kind of L4 behaviors of the system and the L7 behaviors of the system. That gives us flexibility, right? I can go have a different implementation of L4 if I want to, as long as the security properties of the system are maintained. And so, I think we'll likely see some experimentation there, for performance reasons or other concerns, right? within the community. I think that will be probably a major area of investigation. And because we have that flexibility, as long as we have interoperability between the L4 layer and the L7 layer, right, we can do that. Similarly, the L7 layer, right, because we've enabled integration, right, we can, if there's a different policy enforcement point that has to be used to talk to a certain type of system, we could talk to it instead, right, instead of the one that we use. Right? Obviously, we're going to package one up that delivers a kind of consistent set of capabilities, and that's what users buy. But sometimes to get and talk to something, you have to go through something else that we don't control, right? Like a cloud edge load balancer.
Yep.
Right. So we've been very careful to make sure that we can start to interoperate with those types of systems as part of this kind of design.
Good stuff. Good stuff, guys. Thank you so much.
And I just really, and one sec, Brian. One thing I wanted to point out is, there's, I said it before, 5.5, 6 years plus of service mesh experience, engineering, and so on that has been put to work here, and like any new feature or architecture, it's going to take some time to harden. But we do want feedback. We want people using it and pushing on it. But I guess I just want to point out it's not like we just invented this out of thin air yesterday because it seemed cool, like people are doing this. But there's a lot of thought and design that went into this. And then just to say one more word about like Louis said, because of the architecture, because of the separation, there will be optimizations in the various data paths, whether that's the routing from the workloads to the proxies themselves. At Solo, we've been very involved in how eBPF will improve these various areas as well, and so that's something we're very actively working on. But yeah, I just wanted to point out that there's some good stuff here. We want feedback. We want people to use it. But it's not just invented yesterday.
Yeah. No, it's like you said, it's well. And the other thing about this is, we've seen this over the years with technology when certain foundational pieces start to get really stable and solidified. Obviously, we've seen Kubernetes go through that. So much of Istio tends to be layered on top of Kubernetes. Kubernetes has become much more stable, much less sort of feature velocity because they focused on stability. And now we're seeing sort of a second generation of innovation happening around service mesh. And that happens because we're seeing more and more companies using it, providing feedback to communities. And so it's going to be an interesting time right now with the announcement, but obviously lots of interesting conversations and discussions will happen at KubeCon in Detroit in a couple of months and kind of throughout the community. So exciting times, guys. Thank you for all the details today, folks. If you're listening and you're going, wow, that's a lot of stuff, there will be a ton of stuff in the show notes, blogs, technical details, demos, and so forth. We'll have links to all those in the show notes. So as you're listening, don't drive off the road thinking about how you'd write this up on a whiteboard. There'll be plenty there for you to dig into as well. So Louis, Christian, thank you so much for the time today. We really, really appreciate it. Folks, with that, I'm going to wrap it up. I want to thank our guest. I want to thank all of you for listening and continue to help us grow the show and grow the community. And with that, we'll wrap it up. We'll talk to you next week.
Thank you for listening to The Cloudcast. Please visit thecloudcast.net to find more shows, show notes, videos, and everything social media.